which we are going to discuss in this particular topic, guys, storage area networking. Let me show you. This is a humongous journey, but this particular topic called storage area networking, we are going to discuss in a very crispy manner. Of course, with regards to all those important terminologies, which are very much important to understand what is the SAN, storage area networking, right? The intention is not to make you guys expert in storage area networking, because there is always a dedicated team for it. But the moment you come to the hyper converged infrastructure, you should know the nitty-gritties of storage area networking, and that too with regards to various protocols and configurations. So agenda is which we are going to discuss. We will be discussing when it comes to details. We will be talking about what is storage area networking, what are the devices, what are terminologies, what are different techniques, what is storage area networking, how do we do it, and very important thing is storage protocol types, file system and the block level storage and file system storage. We will be talking about various storage components like storage arrays, which also includes JBODs, just a bunch of disks. We will be talking about the SAN switches. Guys, this particular session of us about storage area networking is dedicated onto the vendor. This is going to be a vendor specific like Cisco. So we will be talking about Cisco provided SAN switches. What makes one switch so exclusive to cater to the storage area networking requirement? What are various interfaces? We call them as HBAs. We have our CNAs, converged network adapters, and all. We will be talking about those storage interfaces, the interfaces which are used by storage area networking switches. And then we will be talking about three different protocols: iSCSI, fiber channel, and fiber channel over Ethernet. Kindly be noted over here, the most important thing which I will point you out is this and this versus, I'm sorry, small correction. Okay. FIBER versus FIBRE. So many times what happens is we simply get confused between the two similar terms having the same pronunciation, fiber, but this fiber is different. This fiber is talking about the cable type or the media type, and this is talking about the technology. What fiber channel we are talking about over here is nothing but it is a protocol, and it is not the media or the cable we will be talking about. Okay. In this regard, we will come across many terminologies in storage area networking. We will be handling those terminologies. We will be talking about, as I said, I'm now giving you a glimpse of storage. So before it, truly would appreciate. All right, Satish, thank you so much, Satish, and Lakshman for joining. So, as I said, this is not the teaching which I'm going to do. I'm just going to tell you over here what all topics we are going to discuss when it comes to storage area networking. So we will be talking about the definition of storage. We will be setting up a difference between our SAN, storage area networking, WAN, wide area networking, and LAN. I know that most of us, not by every one of us, all of us, we know very well what is LAN, how LAN works, what are various LAN protocols. We know what is wide area networking, how wide area networking works, what protocols are required. But the storage area networking, its components, its purpose is not very clear to many of us. So our focus will be to understand in a most simplest possible manner what is storage area networking and how it works, what purpose it solves, what are various devices, like we can see RAID, we can see optical storage, we can see tape devices, and so many other devices. In this, we will be talking about JBOD, just a bunch of disk. What is this? What is the purpose of JBOD? What is logical unit number? The purpose of logical unit number. What is the technology called arbitrated loop? How this arbitrated loop technology works? What is the disadvantage of this arbitrated loop technology? Where do we happen to see in which device this technology? We will be talking about not only the JBODs, just a bunch of disks. We will be talking about the storage arrays also, the devices which are meant just like JBOD, which are considered to be the target devices. Guys, in case of JBOD versus storage array, it is the technological difference. The purpose is same. So in this particular regard, we will be talking about the RAID, redundant array of independent or inexpensive disk, which is nothing but which is a mechanism, under which our storage device is called storage arrays, which are nothing but which are called target devices. They work. So you know what, as far as configurations are concerned, configurations are simple, but understanding the technology is very important. So with regards to RAID, we will be talking about various RAID volumes like RAID 0. We will be talking about RAID 1, which is called mirroring. RAID 0 is called striping. What is striping? How it is done? We will be talking about combination of both of them called 0-1. We will be talking about a reverse combination of both of them called RAID 10. 10. It should not be read as RAID 10, but it is called as RAID 10. We will be talking about the introduction of RAID 3. What is RAID 3? What is the significance of it? We will be talking about RAID 4, then RAID 5, and RAID 6. Guys, there are different kinds of RAID mechanisms. We will not be entitled to configure these different RAID mechanisms, right? But it is a holistic practice that we should know what are these RAID mechanisms and how do they work. So RAID, which is a mechanism to store or distribute the data among different disks, we will be talking about. Guys, something before coming over to our storage area networking deep dive important discussions about it, we will be talking about the direct attached storage, the network attached storage, and I am 100% sure you must have gone through in your previous studies, as I still remember way back 22 years back, right? My interaction came to DAS, NAS, but not to the SAN. That time SAN was not there. Need not say that you must have gone through the direct attached storage. The purpose of it, an obsolete technology used just in our laptops for the transferring data from our laptop computers to the hard disk, etc. Then comes the network attached storage, where we do have all the devices, our source device, and our network attached storage, the target device, and our file server, all attached in the network. Very popular, still popular to be used. Various operating system vendors, they have their own means of providing this with the help of their own self-developed protocols. Like Windows and Linux, they do have their own network attached storage protocols. All right, we will be talking about it. Then we will come over to the storage area networking. Under storage area networking, important thing is, first of all, what exactly is this storage area networking and why do we need storage area networking? Guys, you know what, I really have to keep myself on track in order to give you introduction of all these things along with your queries and questions within 1 hour. Okay, So talking about storage devices in this, specifically SAN switches, what different kinds of SAN switches by different vendors, Brocade, HP, Cisco, and all, and what are different network interface cards which are used by them, and then storage protocols. What different storage protocols are there? For example, iSCSI, and we will be spending our sufficient time in discussing the topology. Why this particular topology? Because over here you can see there is a merger of two different technologies. One is called unified computing system and one is called the storage. This is our storage, this blue glowing line, and rest this part is our unified computing system. This part is our unified computing system. This guy is participating into storage, this guy is also participating into the storage, with the difference that this guy is having a different SAN protocol and this guy is having a different SAN protocol. So apparently we will be understanding a cohesive solution between our compute. Guys, I always prohibit myself from calling as server, but we call it as compute. So storage, the intention of this explanation will be just to tell you that there is a cohesiveness we have to establish between our SAN and our unified computing system, which we are going to do over as an introduction over here. But the topology which you are seeing, this particular topology will be holistically implemented in unified computing system in a lab called boot from SAN. That is booting one of our server in this particular box, that is loading the image or the hypervisor into this particular box from the image file which is kept over here or over here. We will be discussing what is the difference, how to connect them. All right. Addressing, various addressing mechanism, iSCSI addressing. All right. Hands-on understanding with regards to fiber channel, we will be doing what is fiber channel. Of course, the very first thing is it is not FIBER, it is FIBRE. Who introduced this? I will be giving an introduction of the organization. Like we know that LAN protocols and WAN protocols are being given by IEEE. There is a separate organization which decided to introduce this particular storage area networking in order to provide high bandwidth and lossless communication between source and the destination. So when it comes to fiber channel, we will be understanding that what makes fiber channel absolutely a lossless communication protocol, right? Because we know that Ethernet is a lossy protocol. Various tunings were done in Ethernet like CSMACD, carrier sense multiple access collision detection, right? So, but no such tunings are required in fiber channel because from day zero, from its infancy stage, it was decided that we are going to make a lossless protocol. So the organization made it a lossless protocol. We are going to see how this protocol is made a lossless protocol. Various devices, various ports, and at every point, when we will be talking about SAN, we will be learning SAN in conjunction with our handsome understanding on LAN. That is, in case of LAN, we do have our ports called access ports, trunk ports, layer 3 ports. We do have certain ports in case of our SAN. We will be trying to establish an analogy between the ports in LAN and the ports in SAN. Okay. I have to cut a long story short. We will be talking about the addressings in case of fiber channel, how the addressing happens. We will be talking about Over here, various fabric services, which are very much automated services. Very minimal configurations are required in case of our storage area networking. And what are those configurations? How the communication happens? What is the important configuration which is required? We will be talking about fiber channel operations. Very beautiful and fancy acronyms called PLOGI, PRLI, and PRLO. Quite impressive acronyms of our fiber channel operations. We will be talking about how the fiber channel operations happen. We will be discussing everything about it, and lot of addressing schemas and guys, pretty important things. And you know what? In LAN we have something called virtual LAN. In SAN we have the similar concept called virtual SAN. So we will be talking about it. And why do we need our virtual SAN concept? We will be learning about. And lastly, not should be called as last, the one of the most important thing which requires a significant configuration, without which our storage area networking cannot work, is nothing but it is called the security rule. By default, storage area networking provides, or you can say does not let the endpoints to talk to each other, because there is implicit deny all, just like we have in the firewall. As we know, in router and in the firewall, what happens is routers, they allow all the traffic by default. We create ACLs to deny the traffic. Opposite happens in case of a firewall. By default, all the traffics are denied. We create ACLs to allow the traffic. The same is there in storage area networking, which means by default, the SAN switches, they do not allow the communication. We have to allow the traffic called zoning. So we are going to see how do we permit communication in case of storage area networking, guys. All right. So in regards to this, I definitely need to tell you about various addressings, the communication establishment, connectivity, and then how to configure and allow the communication between, you know what, this is our source. We have our source residing over here, and this guy is our target. And over here, in between this, we have our SAN switches. So we have to allow the communication between these two devices. Our intermediary device, or device which is causing the interruption in the traffic, is SAN. So we have to provide sufficient security rules to allow the traffic. We are going to look at into that. Okay. Lot many things are there. We will be talking about fiber channel over Ethernet, what makes our fiber channel lossless over a lossy media, right, called Ethernet. Why? We need to introduce, we will be talking about it, that is the convergence between our Ethernet protocol and our fiber channel protocol. Why there came a need to converge them, and how do we converge it in terms of configuration, etc. So pretty important things about it, and it takes time, you know, to explain. I can just give you a glimpse of those, and the configurations also, the configurations which will form integral part of our unified computing system, because in unified computing system we will see the merger of storage area networking. So guys, I would just like to put a pause to my explanation about the SAN. I think this much, you know, will not confuse you, but in case if I go further ahead, it will likely going to confuse you. So before I switch over a high level explanation of unified computing system, let me know explicitly, not implicitly, by keeping questions and queries in your mind, any question you have or doubt which is coming up. Our doors are always open, guys. I truly appreciate, you know, you may be thinking sometimes that you will interrupt the sessions by asking questions, but that's not true. But you directly or indirectly help not me, but every participant in each and every session by asking your questions. All right. Once we are done with SAN in the journey, I thought someone wants to ask a question. All right, no worries. So
Yeah,
once,
sorry to interrupt you, Ashish sir. Naveen here.
not a
Uh,
problem, not a problem. Yeah, Naveen, tell me.
can I ask some question? Sir, I want to
Why
know
not?
that how different between SAF and SAN.
SAF.
Yes, we are using the SAF storage, and what is the
Mhm.
difference between SAN storage and SAF storage?
Can you tell me the full form of SAF?
CEPH, SAF, all-in-one storage, which acquired by the Red Hat.
CEPH. Maybe this is not a technology, but the vendor specific terminology. So personally, I really do not know. If you say, then let me Google it. You said CEPH, right? And SAF storage, Red Hat SAF storage is
Yes,
open
yes,
source
yes, yes.
software defined storage platform that implement object storage on a single distributed computer cluster and provide three-in-one interface for object. If I am not wrong, this is nothing but this SAF storage is a hyper-converged infrastructure. Because when you say three-in-one, three
Mhm.
technologies merging together is nothing but it is a hyper-converged infrastructure. And I strongly believe, though I have never gone through Ceph storage by Red Hat, this is a convergence of LAN, SAN, and unified computing solution. So this becomes the hyper-converged infrastructure, and this is going to be very similar to that of Hyperflex solution, which is going to come to, in the conclusion
Oh,
of this particular journey,
okay, thanks.
right? So it's a good question, a new input and new knowledge for me as well. Any other question, guys? Okay, no worries. Though your questions are very much helpful. And all right, coming over to unified computing system, guys. This unified computing system is Cisco's solution. Well, this particular solution by Cisco was introduced way back in the year 2009. So it is 2022, which is going on, right? So this means it was in the year 2009 when Cisco, you know, got its link separated from various server manufacturing vendors like HPE, and Cisco stepped into the field of servers, not just in terms of manufacturing servers, but in terms of providing a complete integrated solution. Cisco didn't call it as a server system, but Cisco called it as a unified. Unified means a complete integrated solution. Compute over here means, in layman's word, just in layman's word, is server. But the solution is an integrated solution. It is just not the solution of a server. So we are going to talk in this particular journey about, it's a pretty good and long, beautiful journey. What is UCS? Types and evolution of servers, why blade servers over the rack servers, what are various UCS features and benefits, what is stateless computing, which we are going to learn, do, and do the configuration on what are various UCS components. We will be talking in detail about these components very extensively as much as possible. For example, fabric interconnect, various generations of a fabric interconnect have gone through first, second, third, and fourth generation. What chassis, the beauty of the chassis, which has not moved over from first generation to fourth generation, still first generation chassis. Why it is so that we still are using first generation? Then fabric extender. What are the fabric extenders, their function, and fabric interconnect, right? And fabric extenders seems very similar. We are going to look at into the difference. What are various kinds of blade servers? What is virtual interface card? And what is the software which manages all of them, called UCS Manager? All right, so a couple of our friends, I know that some of you must have gone through it, as I can understand. Gen B, you said you have already worked on UCS, or probably you're working on UCS. So you definitely can add more inputs into it. And you can see, in case if we are able to add some extra inputs into your knowledge in this session, we will be talking about a complete architecture and just not a server. So this solution which we are going to discuss is a complete architecture. It is an architecture of servers. We will not be talking about the servers, their evolution, but yes, servers, they have evolved. We will be discussing what is a blade server and what is the advantage of going for blade server. We will be talking about the complete architecture, and in this architecture, the limitation of this architecture, the scalability of this architecture, to what extent can we scale this architecture. We are going to discuss about a very big buzzword called stateless computing. What is this stateless computing, right? Why we need to do this? Because apparently our lab will be based on this stateless computing only, guys. So it will be extremely theoretical if I just explain you stateless computing in just my lab number 14. It's a long journey, but I can say that our journey on understanding UCS will end on implementing the stateless computing concept of it, that we'll be discussing about, and what different components which we configure during stateless computing, what are various devices or components participating into that architecture. Fabric interconnect, first generation, second generation, okay, third generation is also there, and fourth generation I do explain you. And similarly, our chassis input output modules, right? IOMs, also known as packs, fabric extenders, and then interface cards. Lot many things are there, guys. Systematic arrangement and connectivity between them is what we need to learn. So these are different components. What is this? This is a complete rack. What do we have in this rack? In this rack, we have the devices here. You can see these all devices, they are different kinds of devices. So we will be understanding the interconnectivity between these devices. All right, the connectivity, front, rear, and deep dive in terms of understanding the internal connectivity between those components inside a chassis, and the placement of so-called switches inside the chassis, and what do we achieve out of it. What is fabric interconnect? As I said, first generation, second, third, and fourth generation of a device which looks like a switch, but it is not called as a switch, because by default the switching capability of this device is disabled. So this device is meant for a separate purpose. We will be looking at into this device from that purpose. right? This particular device, what you are seeing over here, this device is installed not only with NXOS operating system, but this device is installed with a GUI based application manager, which we will get the access on, and we do the configuration. So device we are going to look at into from its internal point of view, from its rear, from its front, from the interface point of view. How to change the port types of this device from our GUI, we are going to look at into that as well. And in case if we want to connect to the CLI of this device for the purpose of troubleshooting, how to do that as well is part of it. What operating system and what application is installed. This application, which is a GUI based application, this is here to trigger the configurations in our Nexus operating system, NXOS. So it's a beautiful device for
Just a
us,
question.
significant. Please, my pleasure. Go ahead.
Is this the GUI available as simulated, or is it? Uh,
Okay, good question. And this question is from none other than Kuljit, right?
yeah, I hope it is not too. Um,
No, not at all. Your voice is just echoing, so that's the reason I just wanted to confirm. All right, beautiful, Kuljit. The demonstration will be on a simulator. I'm so sorry, I do not have the hardware device to show it to you, but the lab demonstration, I will be demonstrating you the lab both on simulator as well as my previous recordings of my demonstration on the hardware device. Presently, I do not have the hardware in my hand, and thanks to COVID, that's one. Thanks to COVID, not that I do not have it. Thanks to COVID for giving me a leverage to have, my arms spread over a big cloud-based simulator available. And that's not for me, but that's available for all of you. And that's not for on specific days or timings. That's available 24/7, 365 days. Yeah. Where there is a will to learn, there is no end to the facility. All right. Good question, guys. Please feel absolutely free if in case if you have any critical question during my explanation, and immediately stop me, pause me at that particular moment to get the honest answer to your question. No marketing stunts, because our journey is not 1 hour or few days of journey. It's a month long. It's lifelong journey. Okay, I will be explaining you all those things and fabric interconnect, various generations, fourth generation. All right, all right, all right. Then what are fabric extenders? IOMs, where do we fit them? How the internal connectivity between our fabric extenders, right, and the servers. And this is our fabric extender. This is the one. This is a guy who helps us to connect with this guy. And with this guy, what is this guy? This guy is a server. What is this guy? This guy looks like this guy. It looks like a switch, but it is not a switch. This guy is known as FI or fabric interconnect. We will be seeing with the purpose of this guy. All right, guys, something very, very important. And again, 4 generations of this. And you know what? A very important thing, very, very important thing is the understanding the internal anatomy and the connectivity of number 1, server. Number 2, we have our fabric interconnect. And number 3, we have our facts. All these connectivity, guys, what diagram you are seeing, it is schematic presentation of the internal connectivity between this. Why is it so? in order to understand from where the management traffic goes, from where the data plane traffic goes. The management traffic is for the purpose of configuring, pushing the configurations on the servers. The data plane traffic is for the purpose of sending the data from the servers to the LAN, to WAN, to the storage area networking. So in this schematic diagram, we will be understanding a complete internal anatomical connectivity of our server, our fabric extender and fabric interconnect, and of course post that beyond that. All right, very important, and I will give you a complete overall picture on the UCS, right? UCS, LAN and the SAN connectivity. So over here in this particular explanation, we will see LAN as separate, UCS as separate, and SAN as separate. Guys, our ultimate objective is convergence of all these different solutions called our hyperflex solution. Hyperflex in short is written as HX and not as HF. Okay, blade servers. We will be talking about our blade servers. We will be talking about the cards in the blade servers. So the placement of the cards, I'll show you by removing card, in a 3D presentation, where the placement of various cards are there. These are the beautiful things, I just don't want to. I just want to live. I'm trying to lure you to learn these things. You know what? And it's pretty important. If you do not understand the internal anatomy of the connectivity, there is no point of undergoing the compute learning. It's incomplete without understanding the anatomy. So I'm trying to lure you, instigate you to learn if you really interested into. All right, internal architecture. All right, so one more time, and then the application manager, which will help us. And I would like to just give you a quick review of the beautiful lab which we will be doing. Of course, switching type, something very important before undergoing the lab. All right, anyway, it's a big journey. You can see, and that I have moved over to slide number 154 and so on. Okay, and jumping over to the lab called boot from SAN lab. The lab, which at a high level is going to be divided into three major components. One is UCS, second is storage switch, and third is storage array configuration, which is not applicable. We are not given a leverage to configure the target storage machine. There is always a dedicated team. We will not be given that. And understanding the entire topology, our lab is going to be divided into four major tasks: physical connectivity, pools, policies, and service profile. And our lab will have 10 different tasks to be completed. Once these 10 different tasks are completed, you will happen to see that one of the server in our UCS solution gets booted up by installing in it the VMware provided ESXi image called the hypervisor. Once our server, through zero touch provisioning, once our server gets the image, gets booted up, then we can say that our lab, our UCS accomplishment is done. All right, now we'll take not more than 15 more minutes of your precious time. This is what I am being allocated